did this yesterday. We did this one yesterday. Map your sine curve or your cosine curve and do your reciprocal off of that. This was the reciprocal of the cosine. So I mapped my cosine curve. Where your zeros go through, the x-axis, is where you can't take a reciprocal, because you can't put 0 over 1 and make it 1 over 0. You can't divide by a 0. So that becomes your exceptions. These guys here. These are now your exceptions. Your domain restrictions. Work it out like this first. This is pi over 9, pi over 2, 90. This is 3 pi over 2, 270. Notice you've got the odds. N pi over 2, where n is an odd integer. You can use all real except the easiest way to start. The range is exactly the opposite of the sine and the cosine. The sine and the cosine go from -1 to 1. Their reciprocals go from -infinity to -1 or 1 to infinity. God bless you. You okay with that part? Okay. This part down here, the one with the tangent, all I really want you to remember, I didn't flip them over on you, but all I really want you to remember is where is your domain restriction? Where is our restriction when we did the inverses? The domain for the tangent was from the -90 to the +90, but you couldn't use 90. Anybody remember the restriction for the sine? Think of your sine curve. Cut it off before it fails your vertical line test. Your horizontal line test. So, what's down here? -90 to 90. But these you can use. Your cosine curve says cut it here, cut it here. This is the 0 to 180. So those are your restrictions for your inverses, for your true inverses. So sine and cosine are restricted to 1 and 4. Sine and tangent are restricted to 1 and 4. And cosine is restricted to 1 and 2. Remember when you do your inverses and they look like this? Sometimes you see arc. Sometimes you see sine to the -1. Those are your inverses. Just remember to what quadrants those are restricted to. And the cosecant goes off the sine. So here's where your restrictions are. At the 0, at the pi, at the 2 pi. So it's every pi, n pi, where n is any integer. 0, 1, 2, 3, 4, 5, where n is any integer. Okay? Good. All right, stop me if you have any questions. Bacteria growing continuously is PERT. I will give you that formula for PERT. Every time you see continuously, it's a PERT formula. So plug it in. If you start with 6,000 initially, that's your P. Be careful of your rate per hour. And then you want to know how many, so your time has to be in hours, but your answer is to the nearest minute. So when you plug in your time, you're in hours. Your rate, even though it has a decimal, you have to move this decimal 2 places and convert it to a decimal. When you figure out your time, now remember, this exponent only belongs to the 8. So don't multiply it by the 6,000, divide by the 6,000 to isolate your 8. And then you get this, leave it like this, take the ln of both. The only thing that brings an exponent down is a log. If you're using base e, you have to use the natural log, ln. And it's just easier, use ln all the time. Bring the ln down, you can see these will cancel, so it works out to this. And then you're going to divide both sides by 0.102. I put it over there. Now, that answer was in hours. you want it to the nearest minute. So you can leave this in hours, but this is 0.5 of an hour, not 0.5 minutes. How many minutes in an hour? 60. So 0.5 hour is half an hour. If I multiply this by 60, I get 30 minutes, which is to my nearest minute. You can convert the whole thing if you like to minutes, or you can just leave it 6 hours, 30 minutes. When you get a decimal on an hour, and this always gets a little tricky, the 0.5 wasn't so bad. Say it was this. That doesn't mean that's 20 minutes. 0.2 is not 20 minutes. It's 2/10 of an hour, so I have to multiply it by 60. The 0.5, when it says half hour, oh yeah, that's 30 minutes. But anytime you do that, remember to multiply it by the minutes in an hour. Don't just give me like the 20-minute thing. The next one, I think we did this one already. This was repeated from one of the other ones. This was the tell me everything we factored and we reduced this thing. This was from review 3, number 9. I need to clean up my review sheets a little bit better. This one was also repeated from review 3, number 10. These were 2 very hard rational ones. And I explained I didn't give you this. I gave you the short one, the one where it's already on one side. So I'm just going to walk you through one of these. I didn't give you one this hard. But what I was saying yesterday was, whenever you have an inequality, quadratic or rational, you have to get it to one side. So I have to subtract the 7, as I'm looking to see if it's greater than 0, less than 0. I want to know, do I want the positive, do I want the negative? But this part, you need to get on one fraction, one term. It's got to be a rational function. So we had to find a common denominator, and we had to convert all the numerators. In other words, I need this factor, I need this factor. So this guy now needs an x minus 3, this guy needs an x plus 1, this guy needs both. Watch this minus sign, because you have to distribute that over that. Then you're going to collect your terms. You end up like this. So let's just hop down to here, because yours is going to have one term already. So when I'm down here, remember we did zeros of your numerator, zeros of your denominator. We took the numerator, set it equal to 0. We took the denominator, set them equal to 0. This is where you found your critical values. At the 0, at the 13/7, which is almost at 2, at the -1 and the 3. Make sure they go in order. -1, 0, 13/7, 3. The denominator can never be a 0. That one's always open. So the -1 and the positive 3 are open. The numerator uses whatever this is in here. If this is a equal sign, then you can close these signs. I don't care about you getting down to here as long as you can start with this box. Now, you need to test it. This is not like your quadratic where you can draw a parabola. You need to put this into your y1 with the proper parentheses and test. Test to the left, test to the right, test in the middle, and you're looking to see if y is positive or negative. So to the left over here, y was negative. In the middle, it was positive. And then it was negative, then it was positive, then it was negative. You wanted greater than or equal to 0, the positives. This guy, and build your or statement from there. So you want from -1, open bracket, to 0, close bracket, or 13/7, close to 3. Can everybody do from this point down? I'm not too concerned about this. I know you guys still hate fractions. Okay, it's getting a common denominator, converting the numerators, it's just messy. So rather than have you take the time and panic over the fraction, I started you out with one that's already one term on your final. It only has one term. You don't have to convert anything. But you do have to do zeros of your numerator, zeros of your denominator. Okay? The best way to start that is to graph it. Because once you graph it, you can sometimes pull these guys right out of your table. Because they will be your zeros. That will be when your y is 0.
How do you know when it's like open and closed?
If the open or closed, the denominator is always open because the denominator can never be equal to 0. The numerator is based on this sign right here. If it's just a greater than, then it's open. If it's a greater than or equal to, then it's closed. But a denominator is always open because it's a domain restriction. So regardless, can't use that one. Okay, the other one pretty much works the same way. Just bring it down to one term, which yours will be one term. Yours won't even have two factors. My goal is because I want you to know zeros of the numerators, zeros of the denominator. That's the concept behind a rational function. So don't panic on that one. It's not going to, I shouldn't even have that in my review. A divide synthetically, you're going to have to know how to do this. Remember when we had more than one divisor? You're going to take your denominator. The leading coefficient has to be 1, which it is. But if you have 3 terms, if you only have this under your denominator, that's nothing. You set that equal to 0, and your root is this. That's what you would divide by. If you have 2, just take out the coefficients the opposite way. Just give me 1 second. Take that coefficient out opposite. 3, -5. Done it. I was just telling you why. Because if you only have one set of things here, one little x plus 4, set that equal to 0. You have 3 terms here. So you really can't set this equal to 0. You can't even factor this. So you take this term and this term. Just take their coefficients and make them opposite. Pull out a +3, pull out a -5. If my denominator said this, what would my divisor be? 1, -2. Good. This will be a 1. Your leading coefficient will be a 1. If it's not, we would have to factor it out, and then we did one during the year. We factored it out, and we had to divide your remainder by that too when we found what was left over. But I didn't give you that part. I am testing this part. So let's walk through this. Start pulling out your coefficients of your numerator. Remember to use a 0 when you're missing one. After you laid out your coefficients, go back and test it. 5, 4, 3, 2, 1, 0. It's got to go down to the 0. Make sure you have a placeholder. If you don't, your entire answer is wrong. Bring the 1 down. Always start at the left here. 3 times 1, 3. The next time you go right, move it to the right. -5 times 1, -5. Go to the right of the number you just put down. Stop and add the row next to you down. You're here. Start again. 3 times 3, 9 to the right. -5 times 3 to the right. -15. Stop and add this row down. See the pattern? Remember doing this? 3 times 4, 12. Go to the right. -5 times 4, go to the right. -20. Add this row down. 3 times -5 to the right. -5 times -5 to the right. Once you reach this outside, add them both down. Now how do I start? I say this. Look at your leading coefficients. If there's x to the 5th in the numerator, x squared in the denominator, if you divide that, what are you left with? X cubed. Your first one has to start with a cube. X cubed, x squared, x 0, which is nothing, and this is your remainder, x plus something. Remember, when you synthetically divide, if you're not looking for a root, you can absolutely have a remainder. It's your roots that will give you, if it is a root, it will give you the 0 left over. I put another one down here. Determine end behavior, we can call it either way. Synthetically divide or end behavior. End behavior is going to give you an answer. So let's pull this one out. If you didn't do it, do this now. I'll do this with you. Pull out your coefficients. 2, I'm missing a 4, a fourth root. I have a fifth root. I have a square. I'm missing a 1 and a 7. 5, 4, 3, 2, 1, 0. I got them all. This is a 1. Pull this guy out the opposite. 1. Pull this one out the opposite. Good so far? Let's drop the first guy, 2. Start at the left, go to the right. 1 times 2, 2. Negative 1 times 2, go to the right, negative 2. Stop, add this down. Do it again. 1 times 2, go to the right, 4. Negative 1 times 2, go to the right, negative 2. Stop, add this guy down. Start.
The line was 5, negative 2, 4. Isn't it supposed to be 5, negative 2, 2? Because 1 times 2 is 2.
1 times 2 is 2. Yes, what was I doing? I'm talking and speaking at the same time, so let me see what I did here. So 1 times 2 is 2. Good. Sorry about that. I'm glad you caught me. So add this guy down. The 2's cancel out, and I'm left with a 5. 1 times 5, go to the right. 5. 1 times negative 5, negative 5. Stop. Add this guy down. Negative 10 and 5, negative 5. Do it again. 1 times negative 5 to the right. Negative 1 times negative 5 to the right. 5. As you're at the end, add both of these down. This one comes down to negative 10. It doesn't cancel. This guy comes down to a 12. There's your remainder. So an x3 over an x2, an x5 over x2 gives you x3. So 2x cubed plus 2x squared plus 5x minus 5. Here's your remainder over your denominator. Any question?
Where did you get the negative 2 to the negative 8?
The negative 8 came from up here.
No, I'm saying, how'd you get the negative 2 under that?
This negative 2?
Yeah.
This negative 2 came from down here. I multiplied the 1 times the 2 and got a 2, and the negative 1 times the 2 and got a negative 2. You have to multiply from the left to the, go to the right, left to the right, left to the right, just like you read.
Right.
The negative 10, a negative 5 and a negative 5 equals negative 10. Add them. Don't cancel those out.
No, I was saying the 7 is in the next row.
The 7's the next row. The 7's the next row. Okay? Okay, a domain restriction. Now, here's a problem. We're under a radical. A radical cannot be negative. It could be a 0 because we're not in the denominator. God bless you. If we're in the denominator under a radical, then that cannot be 0. So let's first look at our denominator. Our whole radical just has to be greater than or equal to 0. This has its own little issue. This cannot be 0. But is there any number that I could put in for x that will give me a 0 in my denominator? No. So right now my denominator has no domain restriction. So therefore, my numerator has to have a domain restriction because it was going to look like this. My numerator has to be positive or greater than or equal to 0. My denominator is not going to affect this guy because we cleared him already. We said x squared plus 1 equals 0. X squared equals negative 1. Whoops, can't do this. So there's no restrictions in my real numbers. I don't care about my imaginary. No restrictions in my real numbers that I can use. So look towards your numerator. Your numerator has to be positive. It can be a 0, can it? Because I could do 0 over 1. I can get that, so I'm okay with that. But it has to be positive. So I take just this piece out, and I say greater than or equal to 0. Factor it. You've got a quadratic thing going on here. So you're going to have to factor this, find your roots. This was a very hard one. I didn't give you one this hard. I gave you one we looked at once before with the quadratics. I didn't give you one this hard. But here's your roots. So you get a radical cube root of 3. It's approximately 1.4. So then you can figure out where your domain is. Put it on the number line. You have a 0, and you have a radical 3. And this is closed, closed. So you want it to be positive. So your domain can include anything but these two guys. From negative infinity to the 0. From 0 to, whoops. Positive. I guess you're going to have to graph this. Yeah. This way. And then from this guy to this guy. And your range. Did I ask you the range? Yeah, I did. Your range is easy. Coming out of a radical, are you ever going to have a negative number? No. So can you possibly have a 0? Yep. So anything from 0 and above. You just can't have a negative that comes out of a radical. The range is easy. Kyle, that's not your phone, is it?
No.
Good. Because I sure wish it's not and that you're paying attention to this. All right. Compositions. I realize this was a little bit too close together, but what I'm basically asking is always start this at the right, plug in a 2 into the G guy, find your answer, then plug that result into the F. Can everybody do these? Find the equation. This last part, it just said take the equations and subtract them. All you really have to do is distribute that sign. You can't do anything mixing a radical and not a radical. Just some compositions of functions. This is an important one. Your absolute values. Remember your absolute value. Absolute value says that whatever's in here comes out positive. So this can also have a negative answer. It's kind of like this. You're going to have to be careful of this. I can put negatives in here, -4. I can put +4 in here. So I've got two different sets of answers for this. So you have to be careful. Normally on a great OR, you get an OR statement. On the less than, you get an AND statement. This one was a little tough for an AND statement, but I'll walk through this in a second. Make your two paths. Set your OR in the middle. Now, when you do this, keep the first one just as it is. Always remember to isolate your absolute value. In other words, if I had this, I would first have to subtract 2. But this is already isolated. It's by itself. Bring it out the very same way you read it and solve. For the negative sign, bring it out the same way it is in here, but take the negative, and because we took the negative, we had to switch the sign. Now, the only other thing that happens in here is when you divide by a negative, you have to switch the sign. So, this is just reversed. It still works. This is still less than this. This is still greater than this. And then just write your interval. Everybody okay with that? If this were an AND statement, let's do this as an AND. If this were an AND statement this way, once your absolute value is isolated, all you have to do is drop this out and build your AND statement. And solve this simultaneously, like as if you're solving two at the same time. Subtract 2 from both. You're going to still end up with your same numbers, but now your and will go in the middle. So we're going to get a negative 6 less than 2. And you're going to divide everybody by negative 5. So you're going to get 6/5. You're going to have to play around with this. Swap your sign, negative 2/5, and you're just going to have to change everything around. So it's going to be negative 2/5 less than x less than 6/5. But do you see your negative 2/5 and your 6/5 still there? When you have a negative, it just gives you a little bit of grief because when you divide by a negative, you got to flip the sign. So if you come out with something like this because you had to flip your sign, just flip those around. You can still drop it as an and statement and do it that way. This one was a little tougher because of your denominator. You had to find a common denominator. You had to work them all out. I'm not going to spend any time on this one because you're really not going to see one this hard. I really would like to make sure I hit some of the other ones that you'll see. This one is a definite you will see. This is a part 2 type question. A baseball player hits a pitch at an angle with an initial velocity. Remember your parametrics? Okay, you got to set your calc up to parametrics. You got to watch your window. Look at your table to determine what your window should be. You need this formula?
Yeah.
Okay, I'll give you this formula. So the only other thing you have to watch is this. I left the 3 in here, but I somehow took that 3 out. If the pitcher hits it when he hit the ball, if it's 3 feet above the ground, leave the 3 in. If it's not 3 feet above the ground, don't take it out. When I copied it, I must have left it out. So if you don't have the 3, that's fine. Don't forget this negative 16t squared because that's what brings your ball back to Earth. Otherwise, your ball will take off and gravity will never pull it back. So everybody can do this. This is its maximum height. This is when it hits the ground. To check for this guy, to see where the fence is, look to see the distance of your x, your horizontal. When it's as far as 373, look to see what your y is. And he needs to clear a fence. Well, here's his x value. That's closest to 373. Here's his y. So yes, he clears the fence. This is when I think the ball hits the ground, probably. I will give you that formula, if you so desire it. Okay, let's see if we could hit 5. Again, there's your quadratic. Here's your absolute value inequality. Again, isolate it, set it equal to the same thing, flip it around, and use the negative of this guy, and flip the signs, solve them, and then you'll be able to find them. Remember, I did put multiple choice on there, but the choice is there to help you decide how to answer. You still have to show all work. Yeah, this is a good idea. Once you do that, you can check them. Especially, this tells you right away what your roots are going to be. Maybe you know 1 to 4, 1 to 1. Which one's positive, which one's negative. You got to figure it out. Make sure it works. Good. It works just like the last one. A point of discontinuity, remember to factor. The factor that you reduce is your point of discontinuity. We did a bunch of these. Horizontal, I'll give you the 3 rules. When they're the same, it's the ratio. So y is, oh darn. So y is equal to 1. I don't know why that keeps doing that to me. So y is equal to 1 on that one. Here's your horizontal asymptote. It doesn't have a tangent. It has an asymptote. Okay, here's a nice one. Plug it into the F first, then plug it into the G. Take that answer, plug it into the G. Number 4, find me all asymptotes. You have your horizontal rule. After you factor, anything left in your denominator is a vertical asymptote. So make sure you factor out your point of discontinuity, and what is left right here is a vertical asymptote. You only have one horizontal, one vertical. This guy is a point of discontinuity, not an asymptote. Relative min. Everybody can do a relative min on your calc. The limit as x approaches 2. Can I put 2 in there? Yeah, just substitute it right in. Just substitute it in. If it was a negative 2, then I would have to factor and reduce it and use my reduced form. At A, doesn't reach, does it? It's a jump. No limit. Again, here's your difference quotient. Easiest way. Make this be your x. Come down here, wherever you see your x, you plug in x plus h. And then you rewrite this. Then minus, parentheses, the whole thing. Your goal is to factor so that you can factor out the h and eliminate the h. Determine where this is increasing, decreasing. Everybody okay with this? Inflection point? Here's a rational solution. I think this is the same one I did in the other packet, but we did this one or similar together. So how to do this. Zeros of your numerator, zeros of your denominator. Then block them all off. This is how you know. The denominator, always open. The numerator, this happens to be closed. Test it by putting that in your calculator. Alright, can you give me one more minute? Do I have 1 minute?
Yeah.
I have 2 minutes. Okay. Whoa. Okay, bacteria that's growing. Bacteria that's growing, guys. Shh, 1 minute. If it triples every hour, this is your standard. And if you want, I'll give you this too. Just remember, this is where your rate goes into B. This is where your time goes, and you might have like every 5 hours, time over 5. And this one, be careful because even though my time was in hours, I asked 1 day. How many hours in a day? 24. In a week, we had to do 24 times 7. So that one wasn't so bad. We're almost there. The ones from worksheet 7 were your same problems we did in that unit, by the way. Here's your decrease. Here's your decrease formula. If you want, I'll give you this one too. Plug it in. Make sure you decrease. Everybody, I would never do this annually. Annually, just only annually. Quarterly, monthly, I don't know why they're here. I probably forgot to pull this out of there. So if you only books or calculators, books or calculators, I mean. Graphing. Make sure you graph your parent graph first. Here's your parent graph, a basic exponential curve, domain orbital numbers, ranged from 0 to infinity, basic curve right here. transformation. Start where you would put your X. You're going to move a horizontal shift to the right. Come out, the negative gives me a reflection. The +3 gives me a vertical shift up. Then change your domain and your range. The only thing that's going to change is your range and your asymptote. Normally right here is my asymptote, y equals 0. If I shift up 3, I am now y equals 3. So any vertical shift will shift your range and your asymptotes. And the last one, 7, these were maximizing your areas. When you maximize your area, that's what goes into your Y1. So sketch this, a rectangle against a wall. So only 3 sides do we have to account for. So the 3 sides of those, and I just labeled it X and Y. So my perimeter would be 2 plus 2x, 1x, 2x, so plus y. That's my perimeter. This is what I'm maximizing. So solve this for y and substitute this into your equation. This is what goes into my y1. Notice when you return this, your maximum area is your y1. You're going to get a parabola, play with your table so that you can adjust your window because you're not going to see it in your regular window. Your x-min and your y-mins are going to be at zeros. Find me the y that it's maximum at, use your max function. Once you find your x value, find your x value, use your max function, and then plug that in and find your y value. And the next one is very similar. Again, maximize your area. We did this one as a homework problem. You got to set it up and work with your perimeter a little bit. Once you've down pat your perimeter here, solve for y, and do the exact same thing again.